is me, Professor B, and we are going to continue our series on function transformations. If you need to stop the video now and go watch the video that I did on the rules of transformations, go and do that. You can give yourself a refresher, then you can come back and we can talk about these more specific examples, okay? Today we are going to do an exponential function, all right? That means we are going to have some base to a power of our independent variable x, right? B can change to be a bunch of things. It can be a 2, a 7, a 3, a 4.5. It can be lots of things, okay? But so I'm going to give you the basics of the parent function, and then when we talk about more specifics, we will get into those, all right? Some traits that you want to be aware of this parent function. The domain is going to be from negative infinity to infinity. If you look at this graph, it will continue on to the left forever. And even though it looks like it starts getting really, really steep, which it does not go completely vertical. So it will also continue to go to the right forever. Your range, those are your y values. We see that we go up forever, that's the infinity part, but we get really, really close to zero and we'll never touch it, okay? We can't plug anything in for x to make this whole thing go down to zero. So we will have a stopping point at zero, but it is a parenthesis because we'll never actually touch it. With that being in mind, that means we will have a horizontal asymptote at y equals 0. Make sure you have the equation part of that. You can't just put the number 0. We need to know, do you understand, is it vertical, horizontal, whichever? So it does need to be y equals 0, so we know it's a horizontal asymptote. And then one other thing we want to know is our intercept. This one has a y-intercept at 0, 1. Okay? There are no x-intercepts because we don't cross that x-axis. Just for some reference of some points that you can come across, again, these are very generic. We'll get into some specifics when we talk our mild, medium, and spices. For the y-intercept, if you plug in a 0, you're going to get out a 1. Anything to the 0 power is 1, so that's why that point is there. And then for our if you plug in a 1, you're going to get out whatever the base is. Anything to the first power is itself. Okay. And then if you plug in a -1, it turns a reciprocal. So that would be 1 over whatever that base is. Okay. Those just kind of give you some ideas of the traits. We're going to use these to help us determine our shifts and whatnot for our transformations. So if we take a look at our mild example here, notice I have f of x is equal to 2 to the x minus 3 power plus 2. Okay, so that means that we have an exponential function. Okay, so that means the parent function is b to the x, and we're even going to get more specific because we have 2 to the power of x. We know what our base is now, so 2 to the x. What I went ahead and did for you, I labeled this as p of x to show you it is the parent function, and then I went ahead and graphed the parent function for you. So then you can compare that to what the transformation is when we're done. So the parent function has that asymptote of y equals 0. Look, here are all the traits for it over here on the left-hand side. Our range still goes from 0 to infinity, horizontal asymptote, and our intercept. What I've also done down here is notice that I have plotted some points for you. You can do these yourself. You can pick whatever points you would like. All right, I showed you that if you plug in a -1, so that means you have 2 to the -1 power, it ends up being 1/2. If you plug in a 0, 2 to the 0 power, you get 1. Remember, that's your y-intercept. If you were to plug in a 1, that'd be 2 to the first power. That gives you 2. If you were to plug in a 2, that would be 2 to the second power. That would give you 4. That's where I got those numbers from, and I'm going to show you how those can be transformed. So that is how I plotted those points. Okay, so before we get to actually graphing and transforming anything, what we're going to do is we're going to talk about what those transformations are. Right? So the way I like to write down my transformations is I just do them in order that I see them as I read it. So that way I just make sure I get all of them down, and then when it comes to the actual math of it, you'll see that order can change slightly. So the first thing that I come across is this minus 3 because I have a 2 to the x, we determined, that's our parent. So the minus 3 is the first thing that is different from that 2 to the x power. Okay? It is acting upon the x. It is not acting upon the whole thing 2 to the x. It's just subtracting from the x value. So remember, that is a horizontal shift. Okay. Remember from the last video that a horizontal shift, that is your x values, that's a shift to the left or to the right, and your x's are crazy. So while this right now says minus 3, we are actually, instead of moving to the left like you would think, we are going to move to the right 3 units. Okay, so all of our x values are going to move to the right 3 units. Then what I see is I have this plus 2. Now it is acting upon the entire exponential portion. Okay, it's not just acting on the x, it's acting on this whole thing, right? We're adding 2 to it. So since that is the case, this is a vertical shift. All right, that means we are going to be moving up and down, and your y's never lie. So this is going to go up 2 units. That means all of our y values are going to move up 2 units. Okay? When it comes to our domain and range, the domain of the parent function is from negative infinity to infinity. Remember, domain is your x values. All right? So even though we're moving all of our x values to the right 3 units, that doesn't change infinity at all. So this will continue to be from negative infinity to infinity. Excuse me. For our range is your y values. The parent function is from 0 to infinity. All right. However, what we've done with this one, notice we do have a shift here. We have taken our entire picture. So this whole picture is going to move up 2 units. Everything is. So most importantly, that means your horizontal asymptote. Okay, so if the horizontal asymptote moves up, that means the range will as well. So instead of being from 0 to infinity, it's going to start at 2 now and then go to infinity because we shifted everything up 2 units. All right, with that in mind, that means the asymptote has changed. So instead of being at y equals 0, it will be at y equals 2. All right, so everything got bumped up 2 units. For our intercepts, now ordinarily our intercept would be at 0, 1, but since we are moving stuff around, we are going to check this, and the easiest way you can find your y-intercept is to plug in a 0 for your x value. So we're going to find f of 0. That means everywhere I see an x, I'm going to plug in a 0. We've done these evaluations before, so we end up with 2 to the x minus 3, and instead of an x, I'm going to plug in a 0 minus 3 plus 2. Okay? You can plug this into your calculator. Remember, as long as you use those parentheses to help you with the order of operations, you can plug it into your calculator. If you don't, then you can just remember, all right, this is 1/8, depending on how good you are with your multiplication, plus 2. So this is going to be 2 and 1/8, or 17/8, however you want to write it. I prefer improper fractions over mixed numbers every time. So I'm going to write it like that. If you want to write it as a decimal, that's up to you. Okay, so that is our new y-intercept. Okay, so now what we can do is we can start plotting things. The first thing that I'm going to plot is I'm going to plot my new asymptote because I know this guy just gets to move up 2 units. So instead of being at 0, he's going to be at 2. So I'm doing all of this in a different color so you can tell the difference. So the asymptote moves up 2 units. So it's going to be here at y equal 2. There's that guy, y equals 2. Okay, and then the other point we can go ahead and plot is that y-intercept. Again, it's at 0, 2, and an eighth. So I'm going to guesstimate that each one of my tick marks is 1. So that is going to be 2 and an eighth, about there. We'll say it's about there. Okay, so that is 2 things done. Now what we're going to do is we're just going to do the transformations to move this whole thing up. All right. So that, remember, we're moving to the right 3 units and up 2 units. That means every one of our x values, so this is a -1, we're going to add 3 units to it because we're going to move to the right. So that's 0 plus 3. I'm taking each one of these x values right here. I'm going to do 1 plus 3, and I'm going to do 2 plus 3. Okay, so that's going to be 2. It's going to be 2, 3, 4, and 5. Okay. Then what I am going to do is I am going to take all of my y values, these guys, 1, 2, 3, 4. I'm going to take all of those and I'm going to add 2 to them so I can bump them up 2 units. Okay, the y values control the up and down. So I'm going to have 1/2 plus 2. I'm going to have 1 plus 2. I am going to have 2 plus 2, and then I'm going to have 4 plus 2. Okay, so after that, I'm going to clean up those, and I would get 2.5. Again, I prefer improper fractions, or if you want to write the decimal, it's 2.5. It's whatever makes you happy. 1 plus 2 is 3, 2 plus 2 is 4, 4 plus 2 is 6. So these are the coordinates of my new graph. Okay, so we're going to plot 2, 5, 2, 2.5. Okay, and again, I'm going to show you another little trick that you can do. We know that this is the point that we are shifting. Okay, this is the -1, 1/2. We're going to move up 2 and to the right 3. That's what our transformations say. So we're going to move up 2 and to the right 1, 2, 3. So it's going to go right there. Okay, and notice it is 2, 2.5, just like we went there. So we went from -1, 1/2 to 2, 2.5. Same thing. Now watch. This point is going to move, 0, 1 is going to move to 3, 3, because we're going to move it up 2 and to the right 3. So if I start here, I'm going to move it up 1, 2, and to the right 3. 1, 2, 3. And it is at the point 3, 3. Okay. Same thing. I'm going to take this point right here and I'm going to move it up 2 and to the right. 1, 2, 3. And my last point, I'm going to take this point right here, move it up 2 and to the right. 1, 2, 3. So when you're just moving things to the right and to the left, it's real easy. You just move your x values however much you're supposed to move them up, right, or left. Your y values move up and down, and you can shift your whole graph. So all we did was we took the original parent function and we shifted it up 2 units and to the right 3 units. Okay? That is your mild example, all right? And we're going to use these same ideas. We're just going to do things that are slightly more complicated, all right? So let's take a look at the next one. Medium, here we go. Medium example looks like this. We have -3 times 3 to the x minus 1. This is still an exponential function, so we have b to the x as our parent function. We get to be even more specific, saying this is 3 to the x because we know what our base is. Just like before, I graphed your parent function for you to show you those points, and I've even plotted those points down here for you to show them again. Okay, Again, this is that 3 to the x power. If you want to know how I got those points, I took each one of these x values, plugged it in for my x, and simplified to get my y. So we're going to talk through our transformations first, like we did last time. So the first thing that I come across is a negative sign. That is acting upon the entire exponential part, exponential parent function. So that means it is going to be a vertical reflection. And I'm going to put right here, that means over the x-axis. All right. So that means if this guy were a mirror right here, this is just going to flip straight over. So we're going to end up looking like this picture-wise. Okay. The next part that I come across is this 3 right here. That 3 is being multiplied, there's your multiplication symbol, and is being multiplied by our parent function. I'm not taking into consideration this -1 because that's not a part of my parent function, but that 3 is multiplied times our parent function. So that is also going to be a vertical. This time it is a stretch. I know it's a stretch because it is greater than 1, and I am multiplying it times my parent function. So the vertical stretch is by 3. Okay, so we're going to take all of our y values, we are going to multiply them by 3, and we are going to negate them. So we are going to multiply them by a -1. All right. And then last but not least, I see this -1. Okay, again, I'm just picking apart everything that is different from my parent function. The -1 this time, it is acting upon the x. All right, if it were acting upon the whole thing, it would be on the same level. That's why we knew the difference. So since it is acting upon the x, we are now horizontal. It is addition and subtraction, so that's just a shift or a translation. And it is x's are crazy, so says -1, that's not really to the left, that is to the right 1 unit. So all of our x values are going to get pushed to the right 1 unit, adding 1 like we did before. Okay. So if we talk about our domain, range, and asymptote, we have our domain. Our domain is from -infinity to infinity. Even though we're stretching this over and we're reflecting it over, the x values aren't going to change any. So this is still going to be from -infinity to infinity. All right. The range, however, will change. If you remember the picture I drew just a second ago with the highlighter, remember this is our range for our normal function, but since we're reflecting it over that y equals 0 line, that x-axis, we are actually going to end up being a reflection in this way. All right. That means instead of going from 0 to infinity, we're actually starting at -infinity because it'll go down forever. And we always want to start with our smallest value. It'll go down forever, but then it'll stop at 0 because that asymptote is still at 0. All right. We did not shift up or down any since we didn't do that. Our horizontal asymptote is still at y equals 0. And for our intercepts, remember that means we need to find, in this case, it's h, that's the name of our function. And we are going to find h of 0. Okay, so that means we're going to have -3 times 3 to the 0 minus 1. Okay. That'd be, if you're going to use your calculator, that's great. If you don't, it's going to be -3 times 1/3 which is -1. So our intercept, our y-intercept is at 0, -1 this time. Okay. We are going to treat this exactly like we did the last one. We are going to start with our y horizontal asymptote. So that didn't get shifted at all. So all I'm going to do is write it in the different color, but I'm not going to trace it. So y equals 0. All right. But I am going to trace, we have a new y-intercept. It is at 0, -1. Okay. So the first thing that we are going to do is we are going to bump all of our x values to the right 1 unit because that is our horizontal shift. So that's the first thing that you want to do, kind of like an order of operations is a horizontal shift. All right. So this is all going to be -1. Again, we're bumping to the right, so that's adding 1. This is going to be 0 plus 1. This is going to be 1 plus 1. This is going to be 2 plus 1. Okay. So that means we are going to end up with 0, 1, 2, and 3. Those are our new x values. Okay. Our new y values are going to get a reflection and a stretch. Okay. We're going to do the stretch part first. We're going to multiply and then we're going to reflect. All right. So 1/3 is going to be multiplied by the -3. Okay, so that ends up being -1. So, and we know that that's our intercept. Do that in the correct color. All right. Our 1, this guy right here, is going to be multiplied by the -3, because again, that's the stretch and the reflection. The 3 is going to be multiplied by the -3, and the 9 is going to be multiplied by the -3. I might not be able to graph that one because it's going to be a larger number, but that's okay. All right. So 1, -3, that becomes a -3. 3 times -3 becomes a -9, and 9 times -3 becomes a -27. So this is stretching everything over. Okay, we bumped everything to the right one and we stretched it down. So our new points are going to be 0, -1. Our 0, 1, again, it's going to be stretched first. Remember, it's always the stretch first. So we're going to stretch it up 1, 2, 3, but then reflect it. So 1, 2, 3. And then it bumps over to the right 1. So that is going to be at negative, or 1, -3. Okay. Then if we were going to plot the next point, that one's at 2, -9, which is here. Okay. So this one, because we are stretching it, it's going to get really steep really fast, way faster than the other one. Okay. And we will look like this guy. And it's going to get really steep really fast. Okay. All right. That is our medium example. Okay. Got one more example for you guys. I know these are going to be some longer videos. Stick with me. If you want to see a specific example, anything like that, you've got questions, leave them in the comments, okay? So we're going to do one more. This is going to be our spicy example, all right? That just means more transformations. That's all spicy means in this case, is more transformations. So this is still an exponential function. So that means that I have b to the x as my parent. Since I have 2 here, that means my b is a 2, so I have 2 to the x. Again, I drew the parent function for you. Okay, so, and I have the points written down as well. Translations. The first thing that we hit is a reflection. It's that negative again. Because it's acting upon the whole function, that means this is going to be a vertical reflection. Again, that means it is over the x-axis. So this whole thing, again, is going to get flipped on its head. So keep in mind that changes your range. The next thing that I come across is this 2 right here. It is acting upon the x, right? It's not acting upon the 2 to the x, it's acting upon the x. So we know that that means it is horizontal. All right. It is multiplying. So that is a shrink in this case, because remember, if it's greater than 1, it's a shrink. And that is by a factor of 2. Remember, that means we're going to multiply all of, we're going to divide all of our x values by that 2. Okay. The next thing that we come across is the -1. All right. The -1 is also acting upon the x, not the whole function. So that is also horizontal. It is a shift. Your x's are crazy, so this is also going to be to the right 1 unit. All of my examples are to the right 1 unit, huh? And then last but not least, we are going to mention this -3. That's just the order that I'm seeing things in. The -3 is acting upon the entire exponential portion. So we know that that means it is going to be vertical. It is a shift because we are adding or subtracting. Your y's never lie. So that means we are going to move down 3 units. Okay. Once again, our domain, it doesn't matter if you shift this right, left, up, down, reflect it. Our domain is going to stay our domain. So that's kind of nice about these is there are certain things that just won't change. So we are going to go from -infinity to infinity. Okay. Your range will change, okay? We've got 2 things that are going to move our range. First off, we are shifting down 3 units. So that means our asymptote moves down 3 units. Also, we're reflecting over that x-axis. So remember when we reflected over the x-axis, we started with the -infinity because that means that we're moving in the opposite direction, right? But then we're also going to stop since we moved everything down 3 units. We're going to stop at -3 because we moved everything down. Okay. Our asymptote also got moved again since we bumped everything down. Our asymptote got moved to y equals -3. And our intercept, we are going to find the name of this function is g. We are going to find g of 0 to get our y-intercept. Again, there won't be an x-intercept in this case. There can be x-intercepts, just not in this one. Excuse me. So we have -2 to the 2 times 0. minus 1 minus 3. Okay, so again, you can plug that into your calculator, or you can be like me. This would end up being negative 1/2 minus 3, which is equal to negative 3.5 or negative 7/2. So whichever way you want to look at it. All right. So I'm going to start by moving my asymptote first, like I did last time. It gets bumped down 3 units. 1, 2, 3. All right. And then our y asymptote is going to be at negative 3. I'm sorry, I said y asymptote. Our y-intercept, I already did the asymptote. It is at y equals negative 3. Okay. So what makes this spicy? We've got a lot of transformations going on. As long as you know what your order of operations is for transformations, you're going to be just fine. Okay. So for transformations, the first thing that you want to do is you want to do your horizontal shift, and then you're going to do the stretch and the reflect. So for this particular one, for the horizontal portion, we are going to shift it to the right one, and then we are going to divide by 2. Okay, so we are going to take this negative 1. We are going to add 1 to it, and then we are going to divide by 2. So that means we are at negative 1 plus 1 divided by 2. That's 0 divided by 2, which is going to be 0. All right. So then we're going to take 0. We are going to add 1 to it and then divide by 2. So that means that we would be at 1/2. And then we would do 1 plus 1 divided by 2. That means that would be at 1. And then we would be at 2 plus 1 divided by 2. That is either going to be 3/2 or 1.5, whichever way you want to say it. Okay. For our vertical shift, we want to do the reflection first, and then we want to shift it up or down. Okay. So we will do negative 1/2 and then subtract 3. So that ends up being negative 3.5. That's our y-intercept, right? Oops. I want to write it as that mixed number. Okay. We're going to do negative of the 1. I'm taking each point here. Okay. Negative of the 1. So then subtract 3. So that ends up being negative 4. We will take the 2 minus 3. I'm sorry. Make the 2 negative first, then subtract 3. So negative 2 minus 3 is negative 5. excuse me. And then last but not least, we would take the negative of the 4 and then subtract 3. Again, you want to do the reflection first and then shift up or down. That gives you a negative 7. So the points that we plot, we've already plotted our y-intercept, so that's good. But then we have 1/2 negative 4. So 1/2 negative 1, 2, 3, 4. Point there. I would have 1 negative 5. So 1 negative 1, 2, 3, 4, 5. I will have 1.5 negative 7 for the next one. 1.5 negative 1, 2, 3, 4, 5, 6, 7. So this one looks like it's getting squished horizontally. Down like that. There you go. Okay. Again, it kind of looks like someone's squishing it this way and this way. They're squishing it this way. All right. So it looks like it gets steep fast. Okay. There is an example of your spicy one. I know it's a lot to take in. If you need another example, let me know. Keep looking for videos. We're going to do another transformation one. Hopefully, they'll get a little easier. I'll show you how to find these transformations and their parent functions. Um, as always, if you want a specific example or a different example, leave a comment, like the video, subscribe, let me know what you guys need, and I will see you next time in class. Bye.